So today we'll talk about the branch instructions. So again, before we start, let's recall that we have some registers and we tried a lot of instructions so far, and we pretty much explored most of these registers. But today we'll talk about something related to the program counter, which is a 2-byte register. Okay. Now the program counter always holds the address of the next instruction the microprocessor is going to execute. Now how this actually happens? This is actually controlled by the microprocessor, because you never work with the program counter directly, meaning you never just tell the program counter, okay, this is the instruction you are going to execute next. So your program counter automatically knows which will be the next line to be executed. As you know that no matter what you write, when those instructions are loaded into the map, the memory map, every line has an address, which is actually the address of the first byte of the opcode of that instruction. So this program counter actually holds that address, which will be the next instruction to be executed. For an example, if you look at this chart here, I tried to write a couple of lines here. So with every line at the left side, we have also listed the address of the lines. I think we know how to read these addresses, because this is, let's say, your program or the code is starting from the memory location 0000. So basically the address of the first line is 0000, and then the second byte here is, so first byte here is 86, and the second byte here is 23, right? So the address of 23 is 0001, right? So the address of the next byte, which is 8B, is 0002, which is actually the address of the second line. So that's how you can, pretty much count, and you know exactly what will be the address of the next lines. But this is the interesting part. When you are running the first line, look at what you have in the program counter. Program counter automatically loads the address of the next line to be executed. So this is how your microprocessor can tell what will be the next line it will execute. You might be wondering why this is so important, because when you have some lines in sequence, your microprocessor automatically should know what will be the next line, because the program counter doesn't need to tell it. But in cases, this is crucial, because at this point we are looking at the lines just like in sequence. But think about the high level language. When you did C++, okay, or if you have tried any other language, you have seen that we can write loops, right? We can write if statement, case statements. In those cases, what happens, that your programs, meaning all the instructions that you have, they don't run in sequence. Sometimes it's possible that your program jumps from one line and skips like some lines and go to somewhere. Sometimes you keep running the same line again and again, just like the loop, right? So remember, you keep running the same loop. So we have not tried any of those yet, but if that happens, then obviously you have to take care of those, and the program counter actually will tell microprocessor what would be the next line. So for an example, we have some instructions, those are called branch instructions, and we can use those instructions to do the branching. Now the branching means, instead of running all the instructions in sequence, you can skip some lines, you can jump to somewhere else, or you can repeat some lines. I'm saying based on what you need. Okay. Now, so basically, jump means you can transfer the control of the program from one point to another. Okay. So using something called a label. Remember, anytime you write some program, what do? You just start the instruction in your ASM ID. You just start after a tab, right? Why we actually give the tab? The reason we give the tab, because if we need to write any label for any line, we can write a label. Now what is label? The label is something by which we can identify that line. Label is just like a name, so you can give any name to the label. For an example, if you look at this here, so let's say for an example, we have something in the line 1, we are loading something into index register, In line 2, we have an instruction which is called branch instruction. If you go to your instruction set, you'll find this instruction there as well. Okay. Now, the branch instruction actually transfer the control of the program from one place to another. For an example, if you have something like this, let's say branch, and then followed by branch, there is a label. So which is, let's say, label 1, and then your label 1 is here. Your program actually jump from this line to all the way down to here. So basically, it is keeps every single line you have in the middle. That's what I'm saying. So for an example, you might have like another 5 or 10 line here, and all of those lines will be skipped because you said jump to that line. Okay. Branching is sort of like a jumping from somewhere to another. Okay. Now, in those cases, what happens in the program counter is this. For an example, if you look at this here, these are the addresses of the line, right? So after this line, automatically the address of the next line should be 0007. Why? Because since the address of this line is 0004, so that means the address of 7E is 0004, right? So address of the next byte is 0005. Address of the next byte is 0006. So automatically your next line should be starting from 0007. But look at this line here. There is a jump instruction here, right? JMP is like a branching. It actually jumps. Now you will always see that with the jump or branch instruction there must be a label. And the label actually tells where to jump, because otherwise your microprocessor doesn't know where to go. So let's say I gave a name. Don't think that it has to be saved. You can give any other name you want. Okay. Now this is where you have your saved label. So that means after this line, your program will jump all the way here. You might have like plenty of lines in the middle. You might have like 100 lines in the middle. It doesn't matter. Your program will jump to this line. And if you go to the left side of this line, you'll see the address. You see there is a huge jump there, right? Look at the address. That's much far than where you are, right? Now, so that means when you were in this line, your program counter actually will be holding 0200 instead of 0007. And that's how your microprocessor actually will know where the program is going and which would be the next instruction to be executed. Okay? And this program counter updates automatically. I'm saying you don't actually have to take care of the program counter. You cannot even control it. It's automatically controlled. Okay? Now, it's related to branching. So, as you can see, that means in this case, the program counter will be holding 0200. Now, let's talk a little bit about the branching so that we understand the branching and how branching works. We have, of course, two different types of branching. One is called positive branching, one is called negative branching. Now, the positive branching means if you jump forward, meaning let's say you are in line 20, and by using the branch instruction, you jump to line 40. That means you are going further forward, right? Down. Now, that's like positive branching, branching forward. But there can be negative branching. Let's say, for an example, you are in line 20, and you said, okay, can you go back to line 10? So that's like a negative branching. You are going backward. Now, both of these are possible based on your need, but you might be wondering why we are going backward. In some cases, that is true because you might be running a loop. You might want to run the same line 5 times, right? Like what do you do in the loop, right? You want to run same line for like 100 times. So you want to go back to the same, the previous somewhere where you want to repeat the line, okay? So both positive and the negative branching are needed based on your need, based on, what you want to do, okay? We'll talk about this, again, I'm just trying to show you some basic about the branching. To do this branching, we have some branch instructions. If you go back to your instruction set, you will see the list of all this branching. We have never used any of those yet, but we will use those very soon. There are two different kinds of branch instructions. One kind is called unconditional branching. There are only 2 instructions, only 2, which are unconditional. One is JMP which stands for jump. One is BRA, which stands for just branch. Now, why these are unconditional? This means that if you just use any of these two instructions, what happens is your program jumps. I'm saying jumps to where you just asked it to jump without meeting any condition. That means no matter what happens, your program will jump. No matter what happens, okay, your program will jump to that location. Now, but most important branches are actually the ones which are conditional. That means the conditional branches are like, if a certain condition is met, then the branch will occur. That's what I'm saying. If a certain condition is met, then the branch will occur. So you are the one who will set the condition. Who will just say, okay, now if this condition is set or met, branch. Okay. So we are mostly interested about the conditional ones. We probably have to use the unconditional ones, but the unconditional ones like very straight, because if you have the unconditional ones, your program will branch. But if you have the conditional branching, then there will be a condition which needs to be met so that your program branch. And is sometimes if the condition is not met, your program will not branch. Okay. Let us look at a couple of examples so that we understand how the branch works. Again, through this example, we are going to start the branching and then try to understand the branch instructions. But again, as I said, there are several branch instructions, and there is no way we can cover all of these in one lecture. But we'll be, practicing the quizzes, and we'll try to understand this. Now, let's say, again, we are looking at the conditional branches. Now, the conditional branch means the branch will occur if a certain condition is met. Okay. Now, how do I know that what is the condition for the branch? If I go to my set of instruction set, you will find the branches, and in the column 3, you will actually see the test condition, meaning the condition for the branch. So basically, test conditions are listed in the instruction set column 3. Okay. Now, let's look at an example to understand this a little bit better. So here we have 3 lines of instruction. As you can see, in the line 3, we have a branch instruction. And again, always remember that every branch instruction will follow a label. Label is nothing, just a name. Again, label is actually created so that your program actually knows where to branch when the branch occurs. Okay. So let's say for an example, we just used a name here, save. I'm saying don't go by the name. I'm saying it can be any other name based on the criteria that we use to give the name, like the variable names criteria. Okay. Now, so we have to determine here whether the branch will occur or not. Okay. Let's say let's say these 3 lines are given. Okay, and then you are asked, can you tell whether the branch will occur based on these 3 lines? How can you tell? Again, you first have to know what is the condition for this branch. What is the testing condition? As I said, you will always find the testing condition in the column 3 in your instruction set. So if you go to your instruction set and look at your instruction BMI and look at the column 3, you will see the test condition is given like n equals to 1. Interestingly, all the test conditions are given in terms of flags. Now we will see why the flags are so important. We just tried flags, and we are still working on with the flags to understand how the flags are set, when the flags are set. But now you will see the more usefulness of these flags. So the condition is set n equals to 1. Now what this means? This means that this branch occurs when the negative flag is set. That's what I'm saying. Because it's set n equals to 1, n is the negative flag, 1 means set. That means if the negative flag is set, then this branch occurs. That means just by looking at these 3 lines, we have to tell whether the negative flag will be set after we are done with the first 2 lines, because the number 3 is the branching line, right? So let's see what happens in the line in the first 2 lines. In the first line, you are loading a data into accumulator A, right? So so which is 20. In the second line, we are adding another data, which is 34, with what we have in accumulator A. So basically, the operation you are doing is this. You are just adding 20 plus 34, right? And then sum is 54 in hex, which is being which will be again loaded into accumulator A after you are done with the addition, right? Now, look at the sum, and can you tell whether the negative flag will be set or not? Negative flag will not set, right? It's clear, because if you see the answer, this is a positive number, right? 54. So the negative flag will not set. That means after you are done with these 3 lines, your branch will not occur, meaning there will be no branching. But since you wrote this line 3, your program always will match and check whether the branching condition is matching. If the branch condition matches, it will branch through the line that starts with a label save, right? Because we said save here. That means it will actually start with the line, starts with save. Remember when you did the lab 1, at the very last part, you looked at the list file, and then you found the labels. So remember the labels were located at the left side. Some lines had the label, some lines didn't have the label. So these labels are used actually for the branching, okay? Meaning when you have a label, you can tell your program, okay, if something is met, branch to that line, okay? And the label is something which is like an identifier of the line. Let's try some more example. Let's say I have another example with a different instruction. I'm saying different branch instruction. Now this time my branch instruction is BLE. If you go to your instruction set again, you will find all of these instructions, meaning the branch instructions. Now we have to tell whether the branch condition will meet or not, right? After you execute the first 2 lines, okay? Because you have your branch instruction in the line 3. So first step, you have to find the test condition, right? We just look at the column 3, and in the column 3, this is our test condition given. Z plus, within parentheses, n exclusive or V equals to 1. As you can see, all these are flags, right? Z is the 0 flag, n is the negative flag, and V is the overflow flag. All of these are flags. Now let's see what is going on in our first 2 lines. In the first line, you are loading 20 into accumulator B. In the second line, you are subtracting 34 from 20 in accumulator B. You are storing the result into accumulator B again. Now if you look at the operation, this is what you are doing. 20 minus 34, if you do that, your difference would be EC. Okay? Now, to understand this whole operation, you actually need to know 3 flags, right? You need to know what will be the 0 flag, because we have 0 flag here, what will be the N flag, and what will be the V flag. I actually listed all the flags. I know that you don't need the C flag. I still listed the C flag, okay? So after this operation, your C flag will be set. Why? Because the operation had to borrow, right? Remember the C flag also sets in case of subtraction when you have to borrow from outside, because you are subtracting 34 from 20. I'm saying 34 is higher than 20. Then 0 flag is 0, because 0 flag is clear because the answer is not 0, right? So it's cleared. N flag is of course set. Why? Because as you can see, this is a negative number, right? Yes. How can I tell this is a negative number? Because the left digit in the hex number is 8 or more, right? That is E, so that's a negative number. So I know that negative flag is set. How about the V flag? Remember, in case of subtraction, there are 2 conditions when the V flag is set, right? In both conditions, both of these numbers should have different sign. But in this case, first and both of the numbers have the same sign, right? They are both positive. So I'm saying if you go back and check the condition for the V flag, you'll see the V flag will not set because it doesn't fall into any of the cases, meaning we have 2 cases, right? So that's how we know that these will be our flags. Now, let's plug these flags into the testing condition, because we already know the testing condition, and we know that if the testing condition equals to 1, then this branch will occur. Okay? Now this is how we do it. We know that the testing condition, right? So what we did is we plug the values. See how we are plugging the value. We replace the z by 0 because we know that z is 0, right? We replace the n by 1 because we know that n is 1. We replace the v by 0 because we know that v is 0. Once we plugged it, we just do I'm saying just the basic Boolean algebra. How do we do it? See, this is 1 exclusive OR 0. Let's recall the exclusive OR gate. What it does, exclusive OR gate gives you high when when the inputs are different, right? Meaning both of the inputs are opposite. It gives you high. So at this point, both of the inputs are opposite, right? This is 1 and this is 1 and this is 0. So it's opposite. So it gives you high. Now this becomes high, but you already have a 0 here. So now it's an OR gate, 0 plus 1, which of course gives you a high because there is a 1 here, right? Now look at this. After you evaluate this expression using the Boolean algebra, what do you got? 1, right? Which actually matched the condition, because condition said if this, condition said if this condition is 1, then the branch will occur. That means your answer this time is yes. See, in each of these questions, the answer will be either yes or no, because we'll be asking you just like to tell, oh, okay, can you tell whether the branch will occur or not? So the answer will be either yes or no, right? So you have to either select yes or no. So the answer is actually yes this time, because we calculate, meaning we evaluated the expression and we found that the testing condition is met, because the testing condition said, okay, this has to be 1. I'm saying a certain expression is 1, meaning like this expression, this condition is 1, and we found that is 1 for this, for the first 2 lines, right? Any question? We have some more examples, okay? So I'm saying, at this point we're just looking at the examples. Let's try, try to understand a little bit about the branch, the branch instructions we have in our instruction set. We actually have several branch instructions. So this is the complete list of all the branch instructions that we have on the list, on the instruction set, okay? Now, some of these are called signed branching. I'm saying this, I would say signed branch. Some of these are unsigned, and some of these are signed or unsigned. Now this is why it's called signed or unsigned, meaning if you look at the list of the first branches, you will see that in the branching condition, you will have either N flag or V flag. So if you have N flag or V flag in the testing condition, those branch are actually designed to work for the signed numbers. You know that, right? Some numbers are signed, right? Meaning you can write the number and then you can assume that the number is signed or unsigned. And in general, all the numbers are signed, right? Remember, the leftmost bit is, something which represents the sign, meaning if the number is 1, then there's a negative number. I'm talking about the binary leftmost bit, right? That's how we know it, right? Because, in hex, we know that everything starts with 8 or higher. Those are negative, right? How can I tell? Because starting from 8 in the binary is to start with 1, right? Think about the 8. 8 starts with what? 1, 0, 0, 0. Let's start with the 1, right, in the 4th digit. So if your branch testing condition has N flag or V flag, those are actually designed to work with the signed numbers. If those have C flag or Z flag, those are actually designed to work with unsigned numbers. And if you have only Z flag, there are only 2 branches which have only Z flag on the testing condition. So those are good for any numbers, meaning signed or unsigned. Okay, this is actually good to know. Okay, so let's try our next quiz, which is quiz 12. In this quiz, in every question, you'll be given a couple of lines like the ones you have seen in the example. Every line you'll see a branch. I'm saying the last line would be a branch, instruction. Okay, so and then again, if we go to our set of instruction set, you'll find the testing condition in the column 3. So from there, we can evaluate and tell whether the branch will occur or not. Okay, in all of the question, your answer would be yes or no. So all you have to tell whether the branch will occur or not. Okay, so we are not done with all the branching, because in our next lecture we'll again talk about the branching. But this is the starting point of the branching, and these are extremely useful because the branching are the only instructions which will help you understand the loops. or condition codes. Remember, in the high level language, we use plenty of loops. We use the conditional statement like if then else, right, or case statements. So all of those are actually done in the low level language just by using branch instructions. Okay, so these are extremely useful, and as you can see, now you probably will realize that how important the flags are, because all the testing conditions are given in terms of flags. So if you don't understand flags, it's actually hard to find and see whether the condition is met or not, right? So let me stop this presentation here so that we can work on our quizzes.